take a picture for my boss. You can do it now. That's how I get travel approval. I put in my trip report. If you work for AWS, I think Rohini's here. I don't know. We do a trip report on what we learned from you all. So you're an AWS customer, please ping me and tell me what you like, what you don't like about AWS services, EKS, ECS, Lambda, but I mostly work with EKS. So let's get started. This one is a presentation on my recent findings working with enterprise customers that are using ArgoCD, GitOps. There's customers using also FluxCD, but I wanted to make this one specific to Argo because there's specific aspects of it that of Argo that have come up to the light in the recent releases, and also things that have come up like when you're trying to run it in production that I have seen. So these are like my learnings will not be like a tutorial, but like the takeaways like make you aware of what are the things available when you're dealing with GitOps and multi-cluster, and then finding out if ArgoCD may be a tool that will help you accelerate your journey. So to get started, the value of GitOps, just as a general aspect is there's a working group in CNCF called the Open GitOps Working Group, and am I okay with audio?
Sorry.
Sorry. Okay. So the group got started with a bunch of folks from different companies, and then we were trying to define what is GitOps, because there was some tools out there that were before, let's say, ArgoCD or Flux existed, and they were calling their project GitOps. And it's not like they were not GitOps or GitOps is better or not. It's just when we are talking about something, we want to be on the same page of what we're referring to. So in terms of the principles that are on the web page, opengitops.io, I think it is the 4 principles is around the system managed through a declarative manner, as much as possible, of having that information in Git. So being declarative, meaning that static files for the most part. I know that there's a balance there. Then the other is the desired state. So this is reduce the business risk. So this helps you have everything set declarative, so that helps with that. The other one is enhance that audits, so you can have a history of everything that have changed on the production cluster. You have it back in a log, for example, and the log is a Git. And I'll talk a little bit about that and how people use 2 repos to have that audit of like the YAML that you started and the YAML that actually got applied using Git as a log. That's a company that uses AWS and Argo called Intuit. They do that practice. The second one, I have an agent that actually reconciles. And we call it an agent, we call it a controller. Kubernetes, we call them controllers, that reconciles. It goes back to Git, and it makes sure that the information from Git, it gets into etcd, which then there's another reconciler that in Kubernetes that reconciles that desired state. So having that is kind of a pull model, right? It goes to Git. It's not, the manifests are not being pushed. So, and the last one is the observe that I was talking about, having the desired state. So those are the principles of having GitOps. Not that you're using Git to store scripts and then you run them in a laptop, and because you're doing operations and running scripts from a laptop and then the scripts are stored in Git, that's not GitOps. And that was kind of the clarification. So the talk is about ArgoCD multi-cluster, but I want to give an overview of like why are we talking about this. Sometimes when we talk to the IT team or the platform team or the DevOps team, we try to help them identify to the business like why we're switching from one tool to another tool. Because you're using it today, well, it will be faster, but we always have to start from that point. And most of the discussions when it comes into platform or internal developer platform, it starts from the developer, the stakeholder that actually is going to use the system, that we want to have a low cognitive load for that person to concentrate only on developing the application. But as you know, if you work in a cloud native environment and you're a developer, you don't know, not only deal with develop, then you have to learn about containers, and then you have to figure out how you're going to build them, how you're going to test them, how you're going to deploy them, and if I have microservices, how I'm going to route the traffic. And it gets a little bit more complicated as you do. We're talking in the whole track about updates. You're updating Kubernetes clusters on how to do traffic shifting. And the end of all is either the developer is going to be in charge of like fixing bugs when things go wrong, when monitoring is alerting you. But that's the idea. So everything starts with a Kubernetes cluster. They get a Kubernetes cluster. Usually they use a cloud, and then get a second one in that cloud account. But the thing is, as you have more applications, or more teams, and more environments, usually you don't want to mix the dev environment with the production environment. So you end up with two clusters. So this is kind of like the background, like why would you have multiple clusters? And the starting point is having multiple environments. But these large enterprises, they don't only have one team, they have another team. And then this other team gets another cloud account and creates another environment with another cluster. And so on. You have another team that has three environments. We have the pre-prod, we have the CI, and the prod. So that's what these platform teams or DevOps teams are trying to do, is like consolidate everything into the minimal aspect. So it's also a cost optimization aspect of, can they share clusters, basically create namespaces, or organize them, or kind of manage them in a way that the developers kind of like ask for an environment, and then the system decides if they get a new cluster or if they get a namespace, and then they can see they can have more visibility on how the infrastructure gets spent and how the infrastructure gets secured. So that's where it comes the platform team or the DevOps team. If you're small enough, the DevOps team and the platform team may be the same. In some enterprise customers, large customers, they actually have two teams. And the idea is of this internal developer platform, or if you have read some of the blog posts out there or Twitter threads, is platform engineering. From the tag delivery in CNCF, there's a working group on platform engineering. If you want to learn more, contribute, you're welcome to join the CNCF there. But it's, I would say, like, the consumers are the developers are like kind of renting, and then the providers, the owners of the platform usually are the one handling the cloud accounts. They own those accounts, so they're trying to do kind of a chargeback model in these enterprises. So team responsibility. So the end summary is application developers should focus on building the business logic, writing the microservices or writing the functions that run in Kubernetes. DevOps teams help them deliver and build the pipelines, and then the platform teams look at everything across the board on how can they maximize the developer velocity and also minimize the cost and the security risks. So now we go into multiple clusters. So the typical that I've seen with customers is they start with a cloud account, and they create a dev environment, and this includes a EKS cluster, and they put add-ons. We call them add-ons or the toolings that will help you create that cluster or manage that cluster. So things from most of the customers use open source add-ons. We have here some ArgoCD and Cert Manager. Some of the add-ons are from AWS, like AWS Load Balancer or CSI drivers, or autoscalers like Carpenter, which is a popular one. Then the test environment, that account, and they usually create a second account for production to separate the non-prod or pre-prod from production, so they have two accounts. And that's where like the platform engineering starts working in the infrastructure as code or infrastructure GitOps for infrastructure, or defining those environments, so creating a pipeline. So those are the challenges for the platform team of like enforcing best practices across the clusters to have them consistency across of them of like what add-ons are being installed, what version are installed in pre-prod, what versions are installed in prod, how do you test those add-ons in one environment and then promote them to another one, the lifecycle management of the cluster itself, supporting multiple teams with guardrails so they can have their velocity and everything automated. and then the easy way of like, if I want to start a new service or a microservice, how fast can I just bootstrap or scaffold everything? So let's talk about a little bit about the two. I summarize it in two. There's many combinations of them, but at the end of the day, we see two GitOps setup, and this applies also to FluxCD, since people are using FluxCD. But it's the standalone GitOps, where a single ArgoCD instance is in charge of only installing or deploying apps in that cluster. And they share the same Git repo. And there could be another ArgoCD deploying those ArgoCDs. So that's a little bit of the complexity. The benefits of this is that if you're not configuring the authentication, the single sign-on, and the separation of concerns, then the ArgoCD can only affect that cluster. So you have that. Also scaling. If you have a lot of clusters, one ArgoCD instance has its complications on scaling. I'll talk a little bit about that. But this is the standalone, so those are the pros and cons. The other one that I think I'll be talking more about the rest of the talk is, and the majority of the enterprise users, they like to have one single place where they have a single ArgoCD managing the cluster. But what they really are saying is that the production clusters, or all the clusters across where they're running either pre-prod, CI testing, they don't want to have control tooling there because they have control tooling, all the control toolings in this central management cluster. Some of them use things like Backstage or Crossplane or other tools, or maybe they have their CI/CD in the cluster like Tecton or Argo workflows in this cluster, so they want to maximize that cluster to be used as a control plane. The other variation of this, that's why I said there's many variations, but at the end of the day, it stays the same, is if you have a model of vending ArgoCDs, so you can have multiple ArgoCDs in this central cluster, divided either by namespaces or divided something like vCluster, for example, having a vCluster with ArgoCD. So those are the two models. I don't call them pull or push because there's a mix of like this ArgoCD is pulling from Git and then pushing the information to the clusters. The other one is a really more pull, where it's pulling from the Git and then pushing to the itself. So you can say this is a little bit of a push model. So let's get started with like the aspects when you get started with ArgoCD and going to set it up for production. My recommendation is that ArgoCD Helm is the best way to install ArgoCD. If you're using OpenShift, I believe they have an operator called GitOps. So that's also another way to install it. But if you're not using OpenShift, use Helm. I know that the documentation in ArgoCD has the getting started is like kubectl apply a folder, and nobody looks what's in that folder. And they actually go and use it in environments where they're using production or sensitive environments. So I would not recommend that if you're getting started. I would recommend using the Helm. The Helm has a lot of documentation for the values, and it has all the combination of things. Like it's very, very good. There's aspects in the Helm documentation, and if you're like me, that I like to inspect my Helm templates and everything, you actually learn how the thing is configured. The other one is Redis HA. So ArgoCD requires Redis. If you install it by default or you don't enable it in the Helm chart, it comes with like one embedded Redis. So there's an option in the Helm chart that you can enable it with HA, and it would deploy the upstream Redis Helm chart with everything HA. So you can select like how many replicas you want, and if you want to have anti-affinity and have one replica per availability zone. In Amazon, in AWS, we have availability zones with our fault domains, and you have that. And also configure the metrics. And the Helm chart is very up to date. So the end of it is like, I recommend the Helm. The next one is, as you deploy multiple clusters and you have that single cluster, single ArgoCD instance managing all those clusters, you have to register them back. The way that you do it, ArgoCD, even the GUI showed you like the clusters that you're managing. So ArgoCD was designed for multi-cluster. The way that you do it is you create a secret in the ArgoCD instance namespace, so ArgoCD can discover, and have a label like this one on the secret, and then ArgoCD will recognize it as a cluster. One tip that I will say is if you want to configure that cluster where ArgoCD is sitting, and you're using something like application sets, you can configure the cluster as a remote cluster by adding that label. So the local cluster becomes a managed cluster. Like I said, the managed cluster and the local clusters are there, configured as secrets, and the labels. I think that's a duplicate one. One recommendation, best practice is do not use the ArgoCD CLI. It has an option, and it's in the documentation, to register a remote cluster into the ArgoCD instance. I would not recommend that because it will create a service account in the remote cluster. It will create cluster row and cluster row bindings in that remote cluster, and actually give a cluster admin. So at that point, you're giving more permission than you want. So what I recommend is, and also it will grab back the token and insert that token back into the ArgoCD. I know it's very convenient as you have a small environment, a dev environment, but for production, I would just stay away from that, and that's what practitioners do with that. For AWS, we have something called URSA, which is a workload identity or pod identity, and what we do is in the ArgoCD instance, we use an AIM role, and then we allow that AIM role to assume an AIM role in the other accounts where the remote clusters are located. So actually you can configure a second AIM role with a minimal set of permissions to configure that remote cluster. So they don't have cluster admin. And this is what the YAML ArgoCD will look like. So if you inspect some of my examples or this example, you will never see a token. So if somebody steals this secret, they cannot do anything with it because there's no token secret. If you use if you have an environment where you don't have workload identity, then yes, you will have a token here. So you have to do more work to rotate the secret, protect it, and so much. But this is a YAML file that if you feel comfortable putting the account number or something, you can put this in Git and deploy with GitOps. So let's go to scaling challenges. So this is how ArgoCD works internally. ArgoCD is not a single container. That's also a misconception when people get started with ArgoCD. They think it's like one container that does everything. Actually, there's different microservices inside. The first one to the left is the visualize, is the ArgoCD API server. It serves the UI, but it also serves the API request. So the ArgoCD has an API to modify the apps, get the apps, modify the projects, the RBAC, and that scales horizontally. So if you're going to have a lot of requests, then you can set up the number of replicas that you want, and also configure the HPA with the resource and limits. And that's something that you can configure in the Helm chart. So it scales horizontally. As more requests comes in, it can do that. It will have problems with cache, and it will use Redis to cache that information or everything that gets loaded. The critical one is the application controller. That's the one, and you can deploy ArgoCD kind of a headless mode. You can only deploy the ArgoCD application controller and the Argo repo server, and not the API, and you can still continue using the UI from the ArgoCD CLI to launch a UI, temporary UI, and do everything. And you can deploy like that if you don't want access to it. The Argo application controller is a stateful set. So that's usually is configured with 1. And the way that it scales today, and that's something that I started with Acquity, is a SIG Scalability in ArgoCD, is how do we can scale this a little bit smarter. The way it works is if you have one cluster, managing ArgoCD one cluster, then that one replica is the one that will handle that. If you add another replica to that stateful set, it will not help because the charting is based on clusters. So scaling challenges. So for the repo server, which gets the manifest files, it scales horizontally also. So you have to set up your HPA. If you have problems with storage, you will have a PVC. And that's the one that gets the YAML files. In charge of like getting the information from Git, it gets the YAML file, and then it has the plugin mechanism to add that. The application controller is basically scales a number of applications. So if you have a lot of applications, it will not scale that good. If you have multiple clusters, then you will have the stateful set. You can have X number of stateful sets. You can set it in the Helm chart. And then every chart, you can assign it to a different cluster. But in that way, if you have homogeneous clusters, it scales fine. If not, you will have problems with it. And the API server, I mentioned the memory in cache is memory heavy because of the memory in cache. And then the red is make sure that you have it across AZ. And the latest thing is enable compression because it will save you 70% of traffic. So if you are getting charged for AZ cross traffic, that's something that you can help with that. I just talk about the next slide, the lessons there. And these slides will be available. I know some people may not read this, but this is basically the Helm chart where you enable HA, right? HA enable high availability. Set the number of replicas, the minimum replicas, and then configure the resource request. And one tip that I got reminded the other day is when you set up the HPA, the numbers that you put in there are for the requests, not the limits. Moving into monitoring ArgoCD, actually ArgoCD has good metrics, Prometheus metrics, so you just need to set up Prometheus to scrape the metrics from the different components. And then it also provides a Grafana dashboard from the open source community. You may need to tweak them based on how you're collecting the metrics, but that's what we use. And then my examples that I have online, I use a Prometheus as a service and Grafana as a service from AWS, so it's compatible with that. This is kind of like the configuration, again, back to the Helm chart of how to enable metrics so it can be collected from a Prometheus job. I already talked a little bit about this of collecting the metrics. So the metrics that you're collecting are from the different aspects. So API server and repo server are horizontally scaled. So you're looking at CPU and memory. The application controller, the metrics that are important there is like the work queue of how much time it takes to reconcile. And also the sync and the work queue are the most important ones. You see. And these are some of the experiments or like testing that we're doing, that SIG Scalability that I mentioned, of how many apps that you can scale with one cluster, how many apps across clusters. So modifying the resync policy, making it bigger. It helps to work the application controller to work out the work queue. If you have it too small, then it just resets and it never ends. So those are the tweaks and the tuning that you have. So out of the SIG Scalability in ArgoCD, we're going to have documentation on how to set up this. But you can do it today, and some customers are doing today. They're monitoring their ArgoCD with Grafana and Prometheus. This is an example of like if you have 10,000 applications managed by ArgoCD, it will take you 35 minutes to make a change and then reconciles all those workers. And this is a change that is like changing all the 10,000 applications at the same time. I know it's not realistic, but these are kind of a load test. Application sets is what we recommend to, and a lot of practitioners are doing, is to deploy applications across multiple clusters. So you have staging, stat, prod, or 3 prods. You can have application sets that can deploy the applications to the different clusters based on labels. So remember, when you register a cluster, you can put labels and annotations in there, and you can do a match selector to deploy them. One recent thing that I discovered, which I didn't know, I keep discovering things, is Go templating. So you can do things like if and else in applications, so you can have that aspect in there. I usually use templates where you can have fallbacks of values, but Go template is something that I discovered recently, so I recommend using that. These are some of the application sets generators. There are like 3 more in the doc, but these are the most common ones of like deploying based on clusters, also based on files that you have in Git, that you can control how long, how applications are deployed through application sets. Single sign-on, I really recommend when you configure ArgoCD for the enterprise to actually use single sign-on, either the DEX inside, but if you're using something like a cloud provider, then you can use an OIDC, and in Amazon we have Amazon Cognito, and this is the configuration of Amazon Cognito that I have used in my examples. And it works with the CLI, so actually the CLI has a good integration that you can use single sign-on with the Argo CLI, so if you're using the Argo CLI in your CI pipelines, you can use them. ArgoCD projects is something that I also recommend. It helps restrict, and one gotcha is there's an ArgoCD project called default. It allows you to do anything. So if you deploy applications and you don't set a project, it will be default and then it can do anything. So first recommendation is make that, and you cannot delete it, you can modify it. So make it restricted to maybe don't do anything and don't use it, create your own Argo projects. This restrict which, if you associate apps with this project, will restrict like what repo or org or set of repos you're allowed to deploy, which clusters you're allowed to deploy, which namespaces, and then which kind of objects. So if you don't want application teams deploying CRDs or deploying namespaces or cluster roles, you can restrict that and just let them deploy the apps to the applications. The ArgoCD webhook is something that I really recommend. It's very useful for demos when you're giving demos, like internal demos, to show like the capabilities or show people how GitOps works. The webhook is an immediate thing. So if you change something in Git, it will send a webhook to ArgoCD and it would do the sync. Something that you can do also is, instead of waiting the 3 minutes, another thing that I've seen other practitioners do is they disable the resync from our application controller because they have too many apps, remember the 35 minutes, and they only use the webhook. If you use the webhook only, then I recommend something like putting an envoy or proxy in there that will retry that, because if the API server is busy, then it will retry, and if it maybe doesn't work for many retries, then send a notification to the team. And also enable TLS secrets and set up the TLS verify and set up the secret. Plugins are very useful, so ArgoCD supports Helm, Customize, and YAML out of the box, also JSONnet. But if you want to have a more not complex, but like more for these multi-cluster environments, multi-tenancy environments, and using application sets, there's plugins available. You can write your own plugin via a sidecar that you can like deploy different Helm charts from a customized file, or deploy many Helm charts from a Helm file. This is a tip that I learned in GitOpsCon. I was not aware. Very useful. You can actually deploy YAML files from your laptop to ArgoCD without having Git. So sometimes you want to test something, sometimes you want to bootstrap ArgoCD, an initial app. You can do it through the ArgoCD app that would send the manifest files directly with that dash local. The other thing that is very useful is like if you have an app already deployed and you're going to make a change and you're not sure if you want to see the diff, you can use --diff --local with the files in your laptop from that Git checkout that you're about to do a PR, and you can actually see the change without affecting the deployment. This is the Argo Scalability SIG. If you want to join, we have a Slack channel. We meet every other week, and this is where we're looking into how to scale Argo with the community, and there's different companies helping there. And these are some of the resources that I'm working on. We have something called EKS Blueprints. It has working on an example that will be an Argo multi-cluster example that will be merged soon in the V5 of the EKS Blueprints. But we're also using ArgoCD in other environments, building these internal developer platforms using tools like Crossplane and Backstage, and AWS has some examples that people can get started with AWS resources. And that's it.
All right.
You were perfect.
Okay.
Does anyone have any questions for Carlos?
So it was a great talk, thank you. I'm wondering, what is your suggestion on solving the chicken and egg question of setting up the very initial ArgoCD if you could have one? Is that bootstrap function or something else?
Yeah, so that's what I'm working here. If I go back, It depends. I think you're asking if you're creating the cluster with something like Terraform or Crossplane, and how do you create the ArgoCD first in the cluster and then generate the other ones?
It just doesn't really matter if you just have a plain, fresh new AWS account, you whether spin up EKS or whatever, and you want to start using ArgoCD, but you know it's your GitOps tool which is supposed to deploy everything else. So I just wonder what is your go-to?
So there's two patterns. One is the EKS blueprints. The first one is around Terraform. So with Terraform, you would deploy everything AIM, deploy the cluster, and then I'm working on a pattern of creating a secret or a config map that then uses apps of apps or application set, and then that would bootstrap everything else. For Crossplane, is kind of a little bit chicken and the egg. Is Crossplane can create the EKS cluster, and then ArgoCD can be installed in there. So some people use Kind to get bootstrapped. Some other people use EKS CTL to get that first cluster. But I recommend using, a lot of our customers are well into Terraform. So creating a Terraform cluster and then going from there. And we have a pattern on that. But yeah, that's why I was asking. It depends if you're using like something like Crossplane or Terraform. It can go two ways.
Okay, so basically using the infrastructure as code framework
Yeah.
in order to deploy. Okay, thank you.
Anyone else?
Thank you. Curious, you mentioned that homogeneous clusters, when you were talking about scaling considerations for the app controller, you mentioned that homogeneous clusters scale better than heterogeneous clusters. Why?
Because of the ArgoCD application controller is a stateful set. So every replica of that stateful set is independent. So if you have one cluster that has 10,000 apps, and the other ones have 1,000, it's still you have 12,000. So ArgoCD overall, the API server is overwhelmed. The Kube API, so it really doesn't scale. So it really should scale number of apps, not clusters, and that's what in the SIG Scalability we're looking into, like making it smart to rebalance based on application than static clusters.
That makes sense, thank you. And simpler question, what is the annotation for on the secret for the managed cluster credentials? Wouldn't the managed cluster CRD just reference a specific secret name? Like, what's the annotation do?
Oh, the annotation, what it does is, for the ArgoCD instance, it first give me the secrets to find the list of clusters, and there could be many different secrets in there, so you can create a secret for your Git repositories to configure SSH or a cluster, so ArgoCD API needs to know like which secret it is. So they use secrets, they didn't create a CRD to represent a cluster, so it's a choice that they did.
Super. Cool, thank you very much.
All right, we've got time for one or two more. Any more?
Yeah, and we run out of time. That I'll be here today and tomorrow. We can talk on the call.
Just a quick question. I see a lot of EKS stuff. I assume Argo's probably the same thing on AKS for Azure.
If ArgoCD supports AKS?
Yeah, I think it does, right?
Yeah. Any Raspberry Pi. I use it in Nooks at home. Yeah.
Okay. So then the question now becomes, a lot of enterprises, when you're looking at multi-cluster, or you're looking at clusters for LODs or shared clusters, you have a lot of vendor tooling that goes along with that. Do you feel that ArgoCD would be a good solution, maybe versus something like Flux, to run vendor tooling to make sure that that vendor tooling is distributed across all the different clusters, like well and managed? Or do you feel like Flux would do a better job?
You're asking me to choose between my two children.
Sophie's choice here.
So our ArgoCD, as you saw, has the pattern of declarative saying and dynamically saying match selectors to deploy this app or this vendor. Basically, it comes down like a lot of vendor tooling comes as Helm charts. So it's how do you deploy that Helm chart. So ArgoCD will have the application set. that you can say, here's a list of clusters, and then deploy them. Where FluxCD, you will need to have more skills to have the standalone distributed pattern, like every FluxCD configured the same way, pulling from the same place, pointing to the same Helm charts, but you will not have a centralized view unless you go something like WeWorks, Enterprise, and the CD. So I think that for FluxCD, you will need to have more skills, and that's okay. Like some people have more skills, and they're okay to work for that complexity, where ArgoCD comes with some APIs that make it more easier for folks that don't know Kubernetes but can deal with an API.
Right, so if we remove Helm out of the picture then, and we're dealing with flat YAML files, like just manifests without Helm, would you still?
No, it's the same thing. A folder versus a Helm chart. And I'm just talking about Helm chart because a lot of EKS add-ons, and we have the EKS blueprints.
Right.
We just go to the Helm chart because they're very well maintained. And then for vendors that we have add-ons, we have an AWS Marketplace vendor option where they provide plugins that you can install with the EKS cluster, but behind the scenes they're provided as Helm charts. But the complexity is still the same, that view across the clusters. ArgoCD, you can do it from a central place, and FluxCD, you will need to have a pull model that you independently configure all of them equally.
Sorry,
Okay.
it does support push also.
Sorry?
FluxCD also supports push model to remote clusters.
Yeah, it supports that, but it doesn't have a CR that gives you like, here are the 15 clusters with these apps, right?
All right, thank you very much, Carlos. So you've got a 3-minute break, and then we'll be back in here for breaking, fixing, and debugging Kubernetes. I'll see you all soon. Yes.